Hey everybody, I just wanted to do a little video on this neat little add-in for Visual Studio that I'd found for programming the Arduino. It's called Visual Micro. You can read more on it at visualmicro.com, and it plugs right into your Visual Studio. It looks like up to also supports Visual Studio 2008, so everything from 2008 and above it looks like it supports. And I also read online that in a few months it's going to support the Atmel Studio version 6, so that'll be a great plus right there. You don't have to go out and obtain a copy of Visual Studio. You can just download the free version of Atmel Studio 6 and throw this add-in and program your Arduinos that way. Of course, the Visual Studio shell is feature-rich with as far as the autocomplete, the IntelliSense, and just there's too many items to even mention in this video. But anyone who's used that platform before knows how good it is. The real gem of this little add-in, though, is the debugger that you can get. Instead of using all those serial print line statements, you can actually set breakpoints up in your sketch, and it'll open up a little debug box showing you your variables. It's really a great addition to the add-in, being able to use a debugger directly in your code. In order to get the debugger, you do need to register on the forum and request it, but I highly recommend you do. And then the actual add-in, you don't need to. You can actually just download it here. I have both files downloaded and ready to go. I got a copy of Visual Studio 2010. I've got it, did a clean install on it and updated it, so it's all ready to go. I don't have to worry about any conflicts on the install. So let's go ahead and shut this down, and I can start installing these files. I'm assuming, I didn't read any of the documentation, but I'm assuming that we have to install the add-in first, since the debugger probably doesn't know what to do if that add-in's not present. So we'll go ahead and we'll double click that and start the install on it. Typical install dialog box, and we'll click next and next again, and it looks like we're ready to go. Okay, after it goes through and does this little thing, looks like installed with no problems. That was pretty painless. Go ahead and close this dialog, and we'll go ahead and go through the same procedure for the debugger plugin. Hit run, same, and away we go on. Okay, and then after a second or two, that debugger installs without any problems whatsoever. So we'll go ahead and close the window. I should mention here too that it's a good idea to read all the installation instructions on the add-in before you install. And one of the items that we definitely need to do is it needs to be pointed to the Arduino IDE library files. So it needs to know the location of the Arduino exe. So you do need the Arduino libraries starting 101 or above installed, I believe. So anyway, we have that installed. Let's go ahead and fire up our Visual Studio, and it looks like there's a little box that popped up that reminds us that we need to set the location of our Arduino exe file. So okay, well, we can definitely do that. Okay, so we go to our tools, options, come down here to Visual Micro, General, and our Arduino application. We just hit the bullets. Mine is located in my documents folder. You'll have to point yours to your wherever you have your Arduino installed at. Mine is in my documents. Arduino 103. Here we go. Click OK. And looks like we have a couple new drop downs here for the Arduino. Okay. Very nice. Okay, let's go ahead and see what we got here for the projects. We'll go ahead and file new Arduino project. That's nice. Enter the name of the sketch. Let's just go ahead and call it test 1. How about that? Okay, it opens a solution. It has our code template here, similar to our Arduino IDE. Has our properties box down below here to the right. Okay, let's go ahead and I suppose the easiest test to give it would just be to open an existing Arduino sketch. Probably the easiest way, just open Arduino and open one of the example files, just a basic one, analog voltage. Select all, copy that. We'll come back into here and just paste it over the top. And I have my Arduino already set up. It's Arduino, it's an Uno, and I have it on COM9. We'll make sure we get that plugged in there. And as the instructions of the sketch tell you that I've got it set up with a 10K pot. I have the wipers on the plugged into the analog input 0, and the outsides to the 5-volt rail and ground. So I think I'm all ready to go. We'll go ahead and press debug. We'll fire that up. Here's our compiling output window here. It's not very verbose, but that's fine. It tells us that it's compiling test 1, the sketch size, the time, and it started automatically uploading to our board using COM9 and was done uploading. So now if I open up have a serial monitor window over here, if I click on that, and it looks like the sketch is set up for 9600, so we'll set the baud rate to 9600 for the board, and it automatically connects, and we have a voltage reading being pumped out on our serial port, and as I turn the potentiometer, the voltage changes as it should. Okay, well that's great. Pretty painless. We can copy and import existing sketches directly without too much fuss. Let me go ahead and close the COM port here. Let's go ahead and check out that the debugger. We'll get rid of some of these nasty serial lines here. Be good to get rid of those. And then I'm going to go ahead and add a little delay line here and show off our IntelliSense. If you just start a couple letters here, if you press Control Spacebar, it'll bring up your IntelliSense and your autocomplete. We'll hit delay, and then parenthesis, it'll show you that it just needs some kind of a number, so we're just going to delay for 50 milliseconds. Okay, very good. And then to set a breakpoint, all we have to do is come over into the margin and click on it. Then if we right click on the word, we go to our breakpoint, and we'll set it up for when the breakpoint is hit, we can print a message. And this message is nice because we can print text, variables, hit counts, whatever we want to print. So this saves you before to debug through the serial port, you used to have a little description line, text line, and then follow it with a variable. But this is all one shot. So let's go ahead and print out the ADC value. To print the variables, we'll need to enclose them in curly braces. So sensor value. And the volts. Curly brace, type voltage. Okay, that should be it. Another thing is the continue execution. If you don't have that checked, the program is going to stop and go to single step mode. So we'll go ahead and leave that continue execution checked. And we'll click OK. Another item is that we have to set up the microvisual debuggers for the project. So we click on the test on your solution here in the test, and we come over to our properties box. If the properties box isn't open by default, you can come up here to your toolbar and open it up. This is our Solution Explorer over here, which is what we're looking at in this box. And over here with the hand and paper is our properties window. So if your properties window is not open, you can just come right up here and pop it open by default. And scroll clear to the bottom here, there's our property name, or our solution name, test 1, and there's another entry there, micro debug. Right now it's set to none. If we set it to full, we'll be able to debug the program. Now we just hit our little green arrow or press F5, or you can come up in the debug window menu item and hit the start debugging. It'll go through, and it opens up this expressions little debug window on our program. And this thing is really cool. To change the different values up here, or the items you want to look at, you can change. You can get a binary reading of your variable, hex, how many times it's been hit, your breakpoint's been encountered, and of course the voltage. If I turn up potentiometer, you can see the voltage starting to change, and all without having to use those nasty print line commands. You might notice down here below in the output, it's showing an output from our micro debug message. We can change that to whatever you want. If you can go back to the build window and take a look at that and see what the building, if there were errors or whatever. But it's a pretty cute little program. The debugger alone is worth its weight in gold. Let me cover another little incident that kind of had me puzzled here for a little bit. Is on our delay, or on our breakpoints. Go back down here and edit it. If you have one of your values in here, if you have a misspelling, it may throw you for a little loop. Here, I'll just drop that L out of the voltage and click OK. And now if we go to try to compile it, it's going to give us an error compiling message. And you're going to think, what in the heck? Well, it's not very verbose. If you go into the text here, it says compiling test 1 for the Arduino Uno, a binary sketch of 732 bytes, compiling debug version test 1 for the Arduino, then the test1.ino in function void loop. Okay, so we're in this function. It says test 1 voltage was not declared in the scope, error compiling. Well, you look in here and say, well, I don't see any voltage. Well, it finally dawned on me after a little bit. Well, it's actually inside the breakpoint. When I set the breakpoint, I'd misspelled voltage, and that really took me for a loop. What in the heck it was complaining about? So just watch that one. The error message needs to be a little bit more verbose in that point. If the error is actually inside the breakpoint, then it needs to let us know that there was an error actually programmed as a little macro in there. I'm sure. I'm not positive on that. I'm guessing, but just keep an eye out for that one. So anyway, that's it should go through, and since the spelling's right, and open back up and show it again very nicely. Again, we'll just turn the potentiometer. And me, watching the variables here, instead of having them fly by on a COM port, is really nice to actually be able to see them and see them in several different formats here. Okay, so let's go ahead and shut this down, and let's go through. I'll show you how to uninstall the program now. So we'll go ahead and shut down Visual Studio, shut down our sketches. And another thing I want to cover is that your Visual Studio, your add-ins, the Arduino programs are going to be in your documents directory. in the Arduino folder that's created, test 1, and this is the solution we were just working on. So that's where your files are going to be located at if you happen to want to grab them from outside for whatever reason. Okay, to uninstall a program, he's got a page that you can how to install the add-in. It's pretty easy. We just go to our control panel and uninstall like any other program, and then to remove the user interface of buttons and menus from Visual Studio, we need to use the reset add-in function that's described here. So just click on that, and it's pretty easy. It's just the Visual Studio applications executable file, the dev environment.exe is we just have to run that exe and pass the reset add-in with the add-in name behind it, and that'll get rid of all that stuff. So let's go through that real quick. Go to our control panel, our programs and features, scroll clear to the bottom, and we have our two visual micros here, and I'm assuming we'll uninstall them in reverse order here. The debug first, and then we'll uninstall the main plugin. I'm not sure it makes any difference, but that's the way I'm going to do it. So we're going to go ahead and click uninstall. Okay, and then it happily goes away, and then we can go to the main plugin, the visual micro for the Arduino, and click uninstall. And it's preparing to remove. I'm sure we're going to hit the UAC in just a moment. There. It should go away here. Well, not too much complaining, hopefully. Okay. Well, we're done there. And now we do have to take that extra step now to remove the menu items. The probably easiest way to do that is to find your environment, or your Visual Studio executable. Let's go to your programs in your Visual Studio and right click and go to properties, and then copy the target. Okay, then we come back down here and open a DOS box by just typing CMD, and paste that in there, add a space, then we'll come right in here and copy that line, and right click and paste that into the DOS box. So this is going to run our Visual Studio executable file with the reset add-in parameter and the name of the add-in. So we just press enter. It should reset that add-in and start Visual Studio up, which it did. And it looks like our Arduino stuff is gone. Very nice. There's also another note in here. We go back to our other page. I think it's on it. Let me take a look here. That it doesn't remove all of the software keys, and you have to go under reg edit reg edit and hack out Visual Micro if you want to remove all the keys. And it's not a hard thing to do. All you have to do is be very careful, though. It's reg edit, and of course it's going to ask you. Then if you come into your computer here, and it's like it says H key current user software. So H key current user, and you scroll down to software, and you go down all the way down till you find the V. You see Visual Micro, and this is going to have all the software keys that are associated with it and in the registry. One of them being the location of the Arduino files that we programmed in. So that's it right there. So if you want to get rid of that, well, you have to, are you sure you want to remove all the subkeys? Yep. But don't do this unless you're absolutely sure you know what you're doing, because you can really mess everything up. And that's why they wrote on the website that can optionally be removed by a person with suitable knowledge. So just be careful with this. It's not too tough. Just watch what you're doing. Hope you liked the video. I plan on doing a couple more videos using the plug-in. I have a SaneSmart LCD button shield I plan on doing a video on. And if you have any comments, be sure to leave me a note down below. And thanks for watching.